Alright, so now I want to explore factoring binomials. The specific kind of binomial I want to look at is a special type, or actually two special types. One called a sum of cubes and one called a difference of cubes. Alright, so here are the formulas actually. The sum of cubes formula, it's a sum, the signs are the same. And a difference of cubes formula, it's a difference, they have opposite signs. So when you're asked to factor a binomial, the first thing you try to do is factor out the GCF. These two terms, the greatest common factor is 1. So I'm not going to have to factor out uh, anything because the GCF is 1. Next, you would check to see if it's one of these two special formulas. Well, this one has opposite signs. The two terms have opposite signs. So it's a difference. So if it is one of these two formulas, it would have to be the difference of cubes. All right. To check to see if this is a difference of cubes, you need to check to see if these two terms here, this one and this one, you need to check to see if they're perfect cubes. So here's how you check that. Here's the check. Well, to check, you need to see if you can find a cube root for 125 x to the third. Basically, you need to figure out if you can find something that you can multiply by itself 3 times to get 125x to the third. And the answer to that is 5x, right? 5x. Think about it. 5x times 5x times 5x, right? If you multiply 5x by itself 3 times, you'll get 125x to the third power. 5 times 5 times 5 will give you 125. X times x times x will give you x to the third. So 5x multiplied by itself 3 times, if you multiply 5x by itself 3 times, you'll get 125x to the third. So it turns out that this first term, the first term, is a perfect cube. So it fits this description right here, which means I can technically say that A is equal to 5x if I'm trying to match this up, because 5x would be raised to the third power to get 125x to the third. A would be then 5x. So it's 5x to the third power. For B, we take a look at this term here, 343, and we take the cube root of that number. Well, the cube root of 343, that we can actually find, that is the number 7, right? 7 times 7 is 49. 49 times 7 is 343. So we found a perfect cube there too. Remember, 7 to the third power is equal to 343. So that means we found our value for B. B is just equal to 7. B is just equal to 7. So in this formula, I have A is 5x and B is 7. So now let's factor this thing then. Let's factor this. All right, from this formula, if I'm going to factor this, I have the left-hand side, right? I have 5x raised to the third power. 5x raised to the third power is 125x cubed. And I have 7 raised to the third power. So minus 7 raised to the third power. So that means I can write it like the right-hand side. So I'll get one term that's a binomial, 5x minus 7, because A is 5x and B is 7. So 5x minus 7. That takes care of this factor. Now let's take a look at the trinomial factor over here. The trinomial factor. So I have A squared. Well, A is 5x, right? If you square 5x, it's multiplying 5x times 5x. 5x times 5x is 25x squared. So this first term in the trinomial is 25x squared. Then plus AB. Well, A times B is 5x times 7. 5x times 7 is 35x. So 35x is the next term. So plus 35x. And then the last term is b squared. B squared. Well, b is 7. 7 squared is 49. 49. So this is then plus 49. All right, this is the factorization of that original binomial. So we've answered the question then. We were asked to factor this polynomial, which is a binomial, and these are the two factors. If you want to check this, you can distribute and combine like terms. You'll get 125x cubed minus 343. Let's look at one more. So this one, once again, we have a difference of cubes. Actually, let me modify this one. Instead of doing 64x to the third minus y to the third, let's do 64x to the third plus y to the third. Let's try this one. So, factor the polynomial. The polynomial is 64x to the third plus y to the third. That one is a sum of cubes. That one is actually a sum of cubes. So, let's go ahead and check to see if these are perfect cubes or find their cube roots, all right? So here's my check. I'm going to check to see if this is indeed a sum of two perfect cubes by finding the cube root of 64x to the third. If I can get something from this that proves that the first is a perfect cube. Let's see, the cube root of 64 is 4, and the cube root of x to the third, that's x. And then let's try the cube root of this term, cube root of y to the third. Well, let's see, the cube root of y to the third is just y. So indeed, I have a sum of two perfect cubes. So I'm going to use not the bottom formula, which is for the difference, but only the top formula for the sum. So let's actually get rid of this bottom formula here. So this is the formula I'm going to use. This one is a sum of two perfect cubes because it is indeed a sum. It's an addition, okay? All right, so let's go ahead and figure out what we're plugging in here. All right, so we have a and b. The cube root of the first term, I'll call that a. So in this case, a is equal to 4x. b, the cube root of the second term, b, is equal to y. So these are my values for a and b here. So I have here, what I have is a cubed plus b cubed. That's what I have. And they're asking me to factor it. So now I'm going to produce the right-hand side, which is going to be, let's see, a plus b, which is 4x plus y. 4x plus y. Multiplied by a squared, which is the square of 4x. 4x times 4x is 16x squared. Then there's a minus sign. Minus. And then AB, well, A times B is 4x times y, 4xy. And then a plus sign, And then we have B squared. B squared is y times y, y squared. And there you have it. This is the factorization of that binomial. So that is how you deal with the sum of cubes and difference of cubes formulas.